51. I was like, but the nice news is that 270 over 51 totally reduces because 3 goes into both. And so technically 270 over 51, that's good, but it reduces to be 90 over, it was 270 over 51, 90 over 17. Oh, perfect, thank you.
What do you guys put in it?
90 over 17. Now wait a minute. Yesterday, didn't I teach you guys how to do this in your calculator?
Yes.
So I want you to throw it in your calculator, and I'm going to keep on solving because guess what? It works, but it doesn't quickly show up like it works. Something's different, something's weird. I want you guys to throw this original system we were working on yesterday. 90 over 17 is right, but my question is whether your calculator will show that to you or not. And whether you can make it show it to you or not. So as you guys are doing that, I'm going to go ahead and finish this puppy up because we were so close to being done. You're putting in the original system, the one that we started yesterday, at the very end of class to try to just cement the idea and make sure you guys knew what was going on. I only have to do one more row of getting zeros to get it in. Wait, what's that form called where you have the whole identity and all the zeros? Gauss-Jordan is a type of elimination, and the form is called reduced row echelon form. Awesome. You guys are remembering that right now because you're doing RREF, right? Not just REF. Okay, do you know how to use your calculator? Okay. But this one's going to be weird. I just said it's different than any of the other ones you saw yesterday. Maybe you saw something like this last night, but it might be helpful to make sure you know how to do it now. I'm going to do, let's see, 3 halves R3 plus R2 to get rid of that, and then negative 3/4 times R3 plus R1 to get that. Nice thing is that's going to stay, that's going to stay. Negative 3 halves plus, 3 halves minus 3 halves is 0. This is a little bit more of a bummer. That's going to be 270 over 34. Yeah. So 270 all over 34 plus 7 times 34. You get a common denominator. Oh yeah, 34 over 34. So that's going to be 8 and 2 is 220, which is going to be 498. I'm hoping something goes in. When 2 goes in, 249 all over 17. Nope, there should be an answer that comes out. And then I have negative 3/4 plus 3/4 is 0. And then I have negative 360 all over. Let's find this 90 over 17 by negative 3/4. Negative, oh no, negative 270. What are you guys getting when you do the RREF? Decimals. Now, you don't want it to be decimals, so check my fractions or your by hand work and maybe another problem. So how can you make that matrix into fractions? Is that a thing your calculator can do? Probably. And multiply this by 32? No, 34? 34 over 34? That's right. I'll reduce this first to make my life a little easier. I'll reduce this to be divided by 2. 135 all over divided by 2 is 34. Okay, I'm going to add that to be 17. 17 times 31. And 90 over 17 come out? Oh, I checked it yesterday. I'm pretty sure it was 90 over 17. Has no one figured out how to do this in their calculator? You got decimals. How do you make a fraction?
If
Perfect. How about 249 over 17?
That's 254 over 17.
Oh, bummer. Did I make a mistake? 498. 498. I thought I was close. People that were with me yesterday. Where'd you go? Did you stay with me or did you disappear?
Everything disappeared when the fractions came.
When the fractions came, that was the first step.
No, I mean like the normal, the abnormal fractions.
Oh, like the
3 over 2,
135 over 2?
Yeah, like 1/2 and 3/4 and 3 over 2.
Wait, this one's right. We're using this one to eliminate those ones. Did you guys at least get to negative 3/2 and 3/4 as the guys who need to get zeros out of it?
I stopped.
Okay, but you had 3/4 and negative 3/2? Yeah? And 7 and 31 over 2? Give me a yeah or no. Someone said they stopped the one before. Did it match up?
I stopped at like 4.
Yeah, no, that's good. The fifth one, that's this one. Did you get 3/4 and negative 3/2 and 31 halves and 7?
I got 3/4 and negative 3/2, and I did my
Really? Aw, I struggle, guys. Well, I guess that's what happens when I rush ahead, and then you guys give up somewhere along the line, huh? We were trying to get it in by the end of the day, by the bell, I should say, by the end of class. Well, that's a bummer. When you work in a group and the whole group peters out on you, and you're stuck by yourself, it's kind of a lonely place to be. So, when you go to college, when you do group work, please don't be that person just to give up and make the other person go ahead and then get mad at them when your lab report is not 100%. Lab reports, they're worth a lot of points and grades. We do the 1/2, which is 7 halves. What? I don't get doing this. You guys do. And you guys were the ones that gave up on me, so it's on you. Let's go ahead and go grade section 8.1. Boop, boop. And let's see how you guys did. I could compare it to a previous year's and show you what the right work is. I could find my own mistakes. It's kind of sad. Because you guys are supposed to be learning on how to collaborate, how to work in groups, how to find hard things, face hard things, and not give up. But I guess we kind of failed that lesson. So section 8.1, you guys can see the beginning. We're going to keep on grading. I'm going to go learn from a previous version of myself where the class did keep up with me. And you guys are going to start grading. So, where?
You have 21 over 2, 20 over 2.
I have 21. You mean 31?
For when you go from 3 to 4.
Mm-hmm. 31 over 2?
You have to do 3 halves times row 2 plus row 3. And I think that's where it got messed up.
Okay. So that'd be 3 halves times 1 plus 3 minus 3 halves is 0. 3 halves, negative 9 fourths, minus 42 fourths, negative 51 fourths. And then 21 halves minus 156 halves. 156 minus 21 is 135. Oh, actually, wait a minute. This fourth row is good, M, because it ended up being 90/17ths. I'm looking at the first and second rows. Yeah, which the second one should have been good, because you could have checked that back here. The negative 3 halves and the 7. The first row might have gone off. That would have been 1/2 minus 1/2 is 0. Negative 3 fourths plus 6 fourths. Negative 3 fourths plus 6 is 3 fourths. 7 halves minus 24 halves. Oh, no, plus 24 halves. Wait. Oh, 7 halves plus 24 halves is 31 halves. Oh.
The problem's in the first row. It's not the second row.
Okay, second row is good.
Yeah. Because it should be 1, negative 5 over 7, 0, and then 6 over 7. That's what my calculator said when I put it in problem for last one.
But that means they would have stopped. They wouldn't have found the 0 way back here. So that's one variation. That's the bummer. So it won't match up with mine perfectly. But it was 5 over 7 and negative 6 over 7?
Negative 5 over 7 and 6 over 7.
Got that one to be 1. Got that to be 90 over 17. We know that. 3/4. If I do my negative 3/4, that goes to be 0. Negative 3 would be negative 270. Oh! Wait. It'd be negative 270. Is that the problem?
Yeah, there's 254 there.
For the second one, though. I'm thinking of the
Yeah,
first one.
254 over 7.
That would be negative 270 over 4 and 17 is 68. Maybe I just didn't multiply that correctly. Maybe that's the problem. And that would have been negative 135 all over 34. Oh, that's the one I was just doing. Bummer. This one would have been 3 halves, which would have been 270 all over 34 plus 31 times 17. Oh, there you go. I multiplied wrong, I think. I just erased it. But I had to get common denominators. That would be over 1. I needed it to be over 34. 7 times 34. 7 times 4 is 8. Carry the 2. 7 times 3 is 21. 23. All over 34, which would be 4, 5. Oh, there he is. 508. All over 34. Dividing both by 2, that would be 254.
Yeah.
Oh, never mind. I was right. I just can't multiply. Multiply 34 times 7 wrong. That's lame. So 90 over 17, and then we have 254 all over 17. And then this last one, we end up with negative 3/4 is negative 270 all over 68. I can divide both by 2. I think I did that correctly. Adding 31 over 2, which I need to get a common denominator. 31 over 2 times 17 over 17. Maybe I wasn't so far off. I do 7 and a 1 is a 21 and a 0 and a 1 and a 3. So I do 5, 27?
Yeah.
All over 34. Is that reduced or is that good? Might have been. I just erased it. I should stop erasing things.
Reduces to 31 over 2.
Oh, that's not 27. I'm pretty sure it's 17 times 7.
It's 527.
And then that reduces to be what?
31 over 2.
17 goes in? Wow.
That's not the rating system.
Oh, the top one's not?
No, that should be 196 over 7.
You guys matched up with me all the way up to here. Did anybody keep going to get me here?
I'll just restart.
Negative 3/4 plus 6/4 is 3/4. 7/2 plus 3/4 is 31/2.
What was wrong about the data or thing that you did yesterday?
Oh, I don't know. I was right here, and I just started going, and so then I did it. When I started going, like finishing it, I multiplied to get common denominators. I multiplied wrong, and so I ended up being right. Just none of you guys checked me all the way up to here, so I didn't know if I made a mistake earlier. But it turns out I just multiplied wrong real quick at the beginning of class, so I got this one off, and then I could have done it again, but I was just completing it using this to get my last one, and then you guys said it was off again. So I'm doing my negative 3/4 row 3 plus row 1. I think I double checked from what you guys said you double checked with me. Negative 3/4 plus 3/4 is 0. I'm trying to do 90 over 17 times negative 3 over 4, which I think is negative 270 over 4 times 17 is 8 carried to 2, 68.
Would you like to
I
subtract
reduced it.
527 to the 135?
527 to the... Oh, I just wrote that down. Thanks, Gene. I didn't actually add down. I was going off of what they said. Got it. So then 527 minus 135 would end up being 4 and then 3 to 82? No, 92. All over 34. Yeah, I just didn't add it down because I ran out of room. So I got a common, I should have added down. And then that would end up reducing to be a 17, and into 3 is 1, and into 19 is 9, and into 2 is 496. Whenever you try to squish scratch work into a tiny space, things go badly. Nicely done. Okay, so section 8.1, reduced row echelon form. We already reviewed that. 3 by 4, talking about the order. We did that a couple days ago. Number 20, oh, we love this one. You were just rewriting him into an augmented matrix. Number 36, you were filling in the blank. Did you get it to be negative 4? How to divide by 3, and divide by 3. Oh, wait a minute. Divide by a negative. Needed a positive one. And then number 46, why was it in row echelon form? Because of the 1s and the 0s below. Not reduced because we're missing up, or we messed up. That reduced row is messed up because we have that 1 up there when we should have had a 0. So yes, row, not reduced row. Number 78, if you did it with a matrix, you would have solved just like we did yesterday, but oh no. But is this a false row or a true row? True, 0 equals 0, that's okay. So therefore we let, well, there is no z, so we let xy equal a. And if y equals a, we plug into the top equation and we solve for x. And then we solve for x. Number 102 was nasty, except I think you were allowed to use... Oh, they used it by hand? That's gnarly. You had to set up something very similar to the systems of equations in section 7. Where was the interest? 7.1 or 7.2? You have 3 different amounts in 3 different accounts totaling $2 million. You have them at different percentage rates for the interest equaling 186, and they gave you one last clue that x is double z. But you would have moved that double z to this side to make it a nice little 3-system equation that we can get into matrices. But I would have made my life so much easier. Well, I think so. If I would have just multiplied everybody here by 100. Why not just multiply everybody by 100? Well, it would be. It'd be 1,860,000. That's true. If you don't like that, I guess you could multiply by a 0.08, but I don't know if I could do that in my head so well. But up to you. They went ahead and got the zeros and then kept on going down into row echelon form. They just said row echelon form because they were like, forget it. I'll just use my plugging in skills. That way they didn't have as much to do on the rest. And then just plug it in, the x and the y, and you end up with your final amount of The zoo got 1.2 million at 8%, 200,000 at 9%, and 600,000 at 12%. They had to do 3 different loans to get the amount of money that they needed. And then I think we're good. But good as in checking the evens. What else do you guys need to see if you need to see anything from homework? Let's get practical, what you guys are dealing with. Anything? Can I do what? Oh, yeah. There you go. Anything else you guys need to see? Odds or evens? Yeah. 79. Priyanka, I'm going to freeze the screen for a second. Let's check out 79. '79 was weird because he had an XYZ. So remember, he's one of those that isn't the right size as he is. Bloop, 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 bloop. He's not like that really nice, even size, but it doesn't mean I still can't put him in a matrix. So what did we do yesterday if we don't have enough rows? Then I what? Add a 0 row, because then we can make it the right size. So you have a 3 by 4. So 0, 0, 0, 0. Whoop. If we were doing our Gauss-Jordan, that means we're getting the 1s and getting the 0s. Remember, we would have to go ahead and get rid of the negative, well, the 3 with the negative 3. That guy's good as he is. Eventually, we are going to have to deal with this and let z equal a, because we're not going to have our z, which is a bummer. But that doesn't mean that I can't put the rest of it in the right form. So if I do negative 3 plus 3, that's 0. Negative 6 plus 7 is 1. Negative 3 plus 6 is 3. And negative 24 plus 26 is 2. Are the row operations okay? Sort of. So I get that 0. Now, ooh, hey, I already have a 1. Now the bummer is, they tell me to do Gauss elimination, Gaussian elimination, or Gauss-Jordan. Gauss-Jordan. So I can't stop. I almost can. I need to get this 0. The nice thing is I don't have to get this 1 or those zeros. I can ignore that third column because it's not there. But I am supposed to get that 0, which means I need to go ahead and do one more multiplying row 2 times the negative to get that guy opposite. So this guy's good as is. This guy's good as is, because I can't get a 1 if there's a 0 without messing up the rest of that row. But now, negative 3 times 0 plus 1, negative 3 times, oh, negative 3, sorry, I should have been negative 2. I need to get rid of that guy. Negative 2 plus 2 is 0. Negative 6 plus 1 is negative 5. And negative 4 plus 8 is 4. But at the end of the day, I'm going to eventually get stuck because it's one of these, I don't have a third row. So I'm going to go ahead and write what I know. So x minus 5z is negative 4. Rewriting that first row as an equation with x's and y's and z's. And then I have y plus 3z is equal to 2, and z equals a. So I can go ahead and plug and check. And leave, double check me. Subtract, I get negative 3a plus 2. And then 5a minus 4. Uh-oh, let's double check.
Oh, yeah.
Oh, I just wrote it wrong. Sometimes it happens. You guys ever done the wrong problem you're supposed to do or written it down wrong? So frustrating. Yeah, right.
On my answers, I never put them in actual coordinates. I just left them
X equals y equals z equals. That's okay. Just think about making it match if you needed to, like a multiple choice. Okay. But I would take it if it was a long answer. That's okay. Any other questions? Was this a hefty section?
No.
Oh, just kidding. I was going to say yes, but we took multiple days on it, so you were supposed to spread it out. But if it wasn't that bad, then you guys are going to like section 8.2. I don't mean that sarcastically. Sorry, did I come across sarcastically? I didn't mean it sarcastically. I mean literally, you're gonna like 8.2. Ooh, I think we're low on water. You can go get water from the teacher's lounge.
Wait, can I?
Yeah.
Actually?
Section 8.2.
I need to get out.
Yeah.
Oh.
Dude, I've been sleeping.
He's the one that's been. He was snoring. You didn't hear it? If it gets him to wake up.
Is there what?
Just pull. There you go. You got it. Okay. Guys, you're gonna like section 8.2 because section 8.2. Okay. Row reducing might come back. Row reducing might come back. It might. But we don't have to really worry about it too much, at least for a couple sections. Yeah. Oh, row reduced echelon form. Row reducing is what we were doing when we took the matrix and tried to get into the identity. Yeah, good question. Sorry. I guess we didn't actually write that down. We were doing row operations to try to reduce the matrix to be the identity. So yeah, hence the row reducing. Good question. But we used to kind of talk about the basics of matrices, which most of you were like, wait a minute, I think this is the part I liked. Maybe not 8.1 stuff, but this stuff. Because technically, you might have something as easy in homework as example number 1. And you might not realize it, but example number 1 is done. This was the answer. Wait, what? Oh, because doesn't this need to be that because it's the first row, first element? In order for two matrices to be equivalent, to be equal, what needs to happen? They need to be the same thing, right? So if they need to be the same thing, then guys, how are you going to solve this example up here? If they're equal, entry by entry needs to be the same.
You said each little thing equal to
Yeah. See it? See it? See it?
That's it.
Wait a minute, those both use x. Well, they better have the same x come out, or else it's impossible for them to be equal. Uh-oh, should have sent KJ to the teacher's lounge. Come on, bud. So then, 2x plus 1 equals 5, 3x equals 6, and 3y minus 5 equals 4. If these were not the same, we'd be in trouble. But are they the same?
What do you do if they're not the same?
It's impossible, no solution, yeah. There was a typo one year, and so it actually was impossible. But now it's good. Wait, what's y equal?
Okay. You said.
Alec, what's y equal? So final answer is 2 and 3. Now this one is actually, well, it might not be talking about an order pair, so Laurel, you might be good on this one. You might be the best on this one, because technically, I think it was just like, hey, we don't know x, we don't know y. I don't think it was supposed to be like an intersection. Because it's just like random unknowns. But. Well, there's no z in this one because we're not talking about x, y, z. And then turn on and let it heat up. But this one was just like, we don't know x, we don't know y. That's why I was kind of taking it out of the intersection because it wasn't a point. It was just like, hey, who's missing? Just like a good old-fashioned variable definition. What are we going to do if you're supposed to add or subtract two matrices? Is this the stuff you like? Nice.
These two counties want to look at the same.
Nice.
Yeah, those were fun.
Those are multiplying. We're getting there. Cross down. Well, I say cross down. I don't know what Mr. Trey said. But I think he's got HPrecalc with me, so maybe he said. Oh, then he might have taught algebra too.
This is easier than other ones to find the x and the y value. This is way easier. It's so much straightforward.
Number 1 was easy because you just add like term by term. Kind of like vectors, right? Horizontals, verticals, right? Oh, wait a minute. Like vectors. I wonder if dot products are like matrix multiplication. Or if matrix multiplication are like dot products. Well, it's hard though because there's so much trig in vectors, you know what I mean? So it's like, do you put matrices after trig or you put matrices? Hey, wait a minute. Number 2. Let's go, guys. You said it was easy.
Oh, wait.
What's wrong?
I said number 1 was
Yes, grimaces all over the place. What should you be telling me? What? They're different.
Matrix operations.
Different shapes. What's the proper term? Different dimensions. That works. Or different orders. Either way.
Different shapes.
They're different orders. They're different dimensions. If they're different orders, different dimensions, guess what's true?
No solution.
You can't add if they're different sizes.
Oh. This is the easy one. I forgot.
Yeah, you can't add or subtract if they're different sizes. Now, if you guys don't want to write out that example, just be like, hey, different sizes, can't add. You just use the words. That works. That works. Okay, this one was lame, I know. But hey, there is an additive identity of matrices. The additive identity of numbers is 0. Add 0 to anything, it stays the same. Matrices, add a 0 matrix to anything, it stays the same. Oh. What's the multiplicative identity?
I don't want to know.
Of numbers, not matrices, of numbers.
Oh,
What do you multiply a number by and it stays the same?
1.
What's the multiplicative inverse? You multiply by and it goes away.
0.
Multiplicative inverse is the reciprocal.
Reciprocate.
Ooh, reciprocate is like reciprocal?
No, never mind.
You should say yes, because it kind of is.
Wait, reciprocate is just make it again. It's reciprocate.
Or is it to flip back on itself?
Yeah.
Ooh.
Like if you give
To return, to flip back?
Kind
Kind of have to make it work. So I'm going to put these examples on the board. I can do dual page if you guys got behind. I just want you to be able to write down the example, and then I'll dual page it if you want to get back. Well, let's get the example down, because if I try to dual page it, you won't be able to see it. So get the example down. Hey, it's kind of like vectors. Look, matrix A plus matrix B, matrix A minus matrix B, 3 times matrix A, and 3A minus 2B. I wonder if matrices can ever show vectors.
Thank you, Emily.
Miss, do you want me to plug it?
You can leave it plugged in unless someone else wants to do it. In case.
Thank you.
Alright, so you guys busted it out?
No.
Yes.
Did you get the example? Can I dual page for those who might have fallen behind?
Yeah.
Turn by turn. Piece by piece.
That's a Slayer song.
Who's Slater?
Oh, not Slayer, Slayer.
Slater. Oh, Slater.
Thrash band from the 80s. Yeah, that's a nice job. Gee, what did you say? See?
Sorry,
You're too tired of
sorry,
saying
I
it.
said no one.
Yeah, just make sure you don't make mistakes. Well, nah, you don't have to write it out. I mean, you can just see A and B and go for it. But I am going to warn you on this guy. Would it be safer to triple A and then double B and then subtract?
Yeah. I think my driving class is
Just saying. Just saying.
My driving class is drivers in the red.
Oh, where are they?
Drivers in the red.
There's
Or-
spoons of it.
That's all my
Spoons in the cabinet.
Dang.
What about triple E?
You can grab a fork too.
Stopped up.
There's spoons in the red cup on the floor.
Those are ideas.
Oh, there's hot cocoa in there too.
Yeah, let's go.
Well, that's true. You could run water through.
Again.
So sorry, we have 4 hours of homework.
So far, so good?
Oh no. For what?
Check it. Are we good?
No. No.
No.
Wait.
I haven't done the class one.
No.
Nice thing is, we already have triple A. We just need to think about double B. Oh, I get it. Triple A. I wouldn't. Nicely done. Nicely done. 3 minus 2 times 2. 3 minus 4 is negative 1. Negative 3 minus plus 2 is negative 1. 6 plus 2 is 8. Negative 3 minus, you're welcome, 16 is negative 19? Oof, I did that way too fast. Double check. I'm going to do 2b just to make sure. 2b or not 2b? But it is no good in the mind to suffer the slings and arrows about
Bees should not be able to fly.
Oh my god.
3 minus 4, negative 3 plus
Yeah,
2,
oh,
6 minus negative 2, negative 3 minus 16.
She
Ha! I was right.
or not the she? That is the question.
I did all my
Woo! How are we doing?
Very good.
This is stuff that we like. Bad. Fun poopers. Hey! If you can multiply in, guess what? You can also
Multiply out.
factor out. Yes, factor out. Clever. Factor out, factor out. What's in common?
She said no one cares my uncle who died in Vietnam. I'm very sad.
Alec, in context of today's class, unless you can draw a comparison, maybe we should.
No one.
Outside 5 minutes.
No.
I'm out. Change that
You
statement
fool, this
to
sentence
Alec.
passed.
Maybe we should change that statement to we shouldn't be talking about this. Not that no one cares.
No one does.
Yeah, no,
Ooh, what can we factor out?
2.
Not a 2.
1/2.
Yes. Yes. Remember, well, no. When you see a common 2 in the denominator, you have to think about pulling out a 1/2. This is actually a very good skill for calculus. You see a common 2, yay, 2. That's the mistake. 1/2.
Player. Calculus player.
If I get my GPA up,
Get it up.
Oh my.
Smell the coffee and the donut holes and be like, calculus. We should do that.
yes. For the dumb holes.
Donut hole.
Oh,
my god, you get your own box.
Oh, you can't.
Too much fun. Boop.
Uh-oh.
Alright.
This game is like fun.
Okay, the next page I'm about to unveil, actually I already did, but I'm going to go back to it. That page, it's going to be a huge long list of what can be true for matrices. It's very similar. What can be true for vectors. I don't want you to see what's there, write down what's there, memorize what's there. I want you to think about what's not there. Look at it. Don't write it down. Don't memorize it. Don't stress about it. I want you to see what's there and figure out what's not there. Can I zoom in? Have we factored out fractions yet?
Yes, we had sheep.
What's not here?
Imagine having batteries in your car.
Yeah, that's
Imagine having headphones with cords.
Imagine.
I literally have.
Let's not ostracize people by saying imagine. There are people that
Want to see my AirPods? Imagine having a
Imagine.
My headphones still have cords.
Mine has one button.
Although, have you guys seen the whole like AirPod holder thing that has a cord and it's like, okay, why not?
Oh
just-
yeah, my AirPods have both.
I think I have
I
one.
want to get.
I guess you have the option of taking it off and putting it on. Either way, ain't nobody got money for that. I mean, here you go. Come back.
We write the chart down.
You don't have to write it down. You don't have to memorize it. I'm curious, as you guys see what's there, I'm curious what's not there.
Subtraction.
But isn't subtraction technically just adding the opposite?
Oh, I didn't know.
No, it's a good idea. But I can make subtraction addition. Does that make sense? I can make subtraction addition by adding a negative 1 time. So technically, subtraction, there's still something that I can do. What's not here? Commutative addition, associative addition, associative scalar multiplication, scalar identity, distribution, additive identity. What's not here? It starts like this.
Matrix.
What's not here? Commutative property. Scalar's here.
Oh.
With numbers, can't you all do a plus b and b plus a as well as a times b and b times a? What's not in this list? Commutative property of multiplication. Why? Because multiplication of one matrix times another is a whole lot harder. Multiplication of one matrix by another is a whole lot harder, and it is not commutative. Addition, yes. Subtraction, well, as long as you add it to do the opposite, yes. But multiplication is a no, a big fat no. A times B does not equal B times N. A times B does not equal B times N. And if you guys want to take a picture of this, you most definitely can. It could be helpful, maybe. Do you need to memorize it? No. But I need you guys to see what was not here. Multiplication is not here. Yes, by scalars. Yes, 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 but not one matrix times another. Not a capital A times a capital B. I'm going to dual page. I see a couple of you still writing this down. Why? Because matrix multiplication, you need to go cross and down. And the question I asked you earlier is if matrices and vectors seem to somewhat tie together, I wonder if matrix and vector multiplication somewhat ties together too. I wonder if matrix and vector multiplication ties together too. Now I'm going to put this in green. You don't need to put it in your notes, but do you remember how when we multiplied two vectors together, we would do u1 times v1 plus u2 times v2? Remember that? Called dot product? You guys didn't know it last year, but every time you did matrix multiplication, going across and down, matching element times element plus element times element, for the very first one, you would have -1 times -3 plus 3 times -4. You were doing a little baby dot product. How many baby dot products do you have to do? One for every single row with every single column. Dot product, dot product, dot product, dot product, dot product, dot product. Cross and down. We'll do matrix multiplication tomorrow. Thanks, guys. I'll see you later. Come by me if you have questions or things that I need to grade, etc.
It's just contraction.
Adios, au revoir, happy Thursday.